Welcome back to the CCNP Route Training from Train Signal. Joe Reinhardt here. We're actually going to continue with our advanced OSPF topics, continuing on our discussion. In this particular part of the lesson, we're going to discuss route summarization, how routes are summarized in OSPF, different types of route filtering functionality. OSPF does things in a very unique way, virtual links, and then finally configuration of all the advanced OSPF lab exercises from the Part 1 and Part 2. So route summarization, let's start there. Why would you want to summarize routes? We'll start with that. We'll talk about how to configure summary routes. There are two types in OSPF. And then how to verify summary routes are operating as expected. So the question naturally comes up, why would you want to summarize routes at all? It's extra configuration, it's extra complexity. Why would you want to do it? Well, the most positive reason has to do with the reduction in size and scope of routing tables. For instance, the 15 networks pictured in the graphic to the left can all be summarized by a single route entry. It can reduce computational time, it can reduce the actual size of the link state database in terms of OSPF, and all sorts of other reasons. Now, there are some drawbacks. It's not a cure-all. One of the things that can happen is less than optimal routing can result because of summarization, and you can have packet discards. If networks contained within the summary are unreachable and the summary is still being advertised, the packets will be discarded. So it needs to be used selectively and with good design practices. Configuring summary routes, there are actually two types in OSPF. One is the area range, and the other is the summary address, which we'll define each one of those. The area range actually summarizes and advertises a summarized route from a particular area on the area border router. It uses the area number range, prefix, and mask command. It'll create a summary route to null zero in the routing table of the router it's configured on, so you'll actually be able to see the summary. More specific routes in the neighbor routing tables will be suppressed in favor of that configured summary, and you can do multiple area range commands to be able to summarize multiple routes. The summary address is not done by the area border router, but by the autonomous system boundary router, and this actually has to do with aggregation of external routes. It uses the summary address prefix mask command. It's not restricted to an area, but it's what's coming into the OSPF process. It's used for summarization of external routes into the OSPF routing domain. And again, more specific routes are going to be suppressed, and it creates a Type 5 LSA for that summary route as well. Remember, we talked about routes that are LSA types that are blocked by certain areas. This creates an LSA Type 5. How do you verify if summary routes are working correctly? Well, show IP route OSPF should list that particularly summarized route. The more specific route should not be there. Show IP route and whatever the specific prefix is should list results. Show IP OSPF summary address should list that summary route. In this case, it happens to do with the summary address, not the area range. Show IP route and the prefix on the originating router should show the route to null zero. And show IP OSPF database should list that summary route in the topology table. These are great ways to be able to verify if the summary route is working as expected. The summary address and the area range command. So just as route summarization can actually aggregate routes, route filtering can actually remove routes from the routing table. And in OSPF, it's unique how that works, and so we're going to talk about the different aspects of that. We're going to see how OSPF deals with that. We're going to figure out how to configure this type of route filtering, and then verify that the route filtering is operating as expected. First, understand that by nature of the OSPF protocol, there are certain filtering functions that are automatically built in already. For instance, a stub and totally stubby area already do route filtering. It'll discard LSA types 3, 4, and 5. The stub, totally stubby, and the NSA, totally NSSA area are already doing a type of route filtering already. You can also do area filtering, where specific LSA type 3 summary LSAs can be filtered. It's configured using the area number, filter list, prefix list, and in this case, in or out command. Another way filtering can be done is preventing routes from even being installed in the IP routing table. What is essentially done here is that it essentially blocks routes from the link state database from being installed in the IP routing table. They'll still be in the link state database, but they won't be in the general IP routing table. It utilizes distribute list commands. Now, distribute lists by their nature can have an in or out direction, but in OSPF it only supports the in option, and that's because it's coming into the IP routing table from the link state database. You can use an ACL, a prefix list, or route map, and the permit statement allows the route to be in the routing table. Deny filters the route from becoming a part of the IP routing table, so understand that logic. To use access lists for route filtering, remember they're standard lists, they're not extended. Always place more specific entries before the more general ones, otherwise you'll filter things out that you don't necessarily want. And you apply it using the distribute list command. The access list filtering syntax is access list, the number or name if it's a named access list, permit or deny, the prefix and the mask involved, and then distribute list. In this case it's only out, remember. You can also optionally put the interface in the command, and the distribute list command is done under the OSPF process. You can also use prefix lists for route matching. They actually allow for both prefix and mask, which access lists really are not capable of doing. You can use a less than or greater than to be able to specify a range of values. Prefix lists can be incredibly complex, but can also give you a very powerful tool for filtering. The syntax is simple. You do prefix list, it's named, permit or deny, the prefix and length, so 192.168.0/24, for example. Less than or equal to, or greater than or equal to, you can actually specify a range, or you can just make a specific range to be filtered. And then you use the distribute list number or name, out, and optionally the interface. Remember, only out direction in OSPF. You can also use route maps, which we've talked a lot about before, so I'll just make this notation and move on, but route maps can be helpful. Now, how do you verify that route filtering is working? Well, if you're using an access list with a distribute list, do the show access list. Make sure the counters are not 0. They should be incrementing if you're actually filtering something. Do show IP route OSPF and confirm the routes you're looking for aren't in the routing table. If they are there, then something's wrong with either the logic or the application of the commands. If you're filtering on all interfaces, you can do the show IP protocols command, and it'll actually say that a filter list has been applied. For prefix lists, the same logic applies. Do show IP prefix lists. See if the counters are non-zero. Make sure they're missing from the routing table if they're supposed to be. And in route map filtering, it's the same type of logic. Virtual links are actually unique to the OSPF protocol. They sort of function like a GRE tunnel, but we're going to actually look at and make sure we understand what a virtual link does, what it is, what functions it performs, how to configure virtual links, and then verify that virtual links are operating as expected. First, using a snippet from our lab to the left, we want to actually understand what virtual links accomplish. If you'll notice, VLAN 79 is OSPF area 79. It's directly connected to area 0 through router 7. OSPF area 910, on the other hand, is not connected to area 0 and therefore violates the rules. And if you actually go into the router interface, it'll say that it's not connected to area 0, and it'll complain over and over and over again until it's fixed. Because the OSPF hierarchy requires that all areas connect to area 0, virtual links create a legitimate exception by using another area as a transit area. For instance, area 79 becomes a transit area to reach OSPF area 0, and then router 10 actually has a direct connection to area 0 and it appears with R7 through a virtual link. Now, when should you use them? Now, honestly, you should use them as little as possible. They're essentially an exception, but if you have good OSPF design, you can avoid these. However, when companies merge, you may be forced to use an area that's not going to be contiguous to area 0, and you may have to use a virtual link for some period of time. In addition, if something happens where part of area 0 is partitioned, a particular link fails, you may end up with temporarily with 2 area 0s, and this is sometimes called the split brain syndrome. And you can actually use a virtual link to be able to keep that from happening. So another legitimate usage of virtual links. Now, this is important. Configuration of virtual links takes place on the area border routers of the transit area. See, we have three routers involved here. Router 7, which has a connection to area 0, router 9, which is an area border router, and router 10. Router 9 and router 7 are the area border routers that are going to be used for the transit, because it's the transit area is area 79. So it's those routers that the virtual link is configured on. So the area number, in this case area 79, virtual link, and not the interface commands, but the router ID of the neighbor, in this case the loopback 0 on each routers, is configured with the area border routers on each side of the transit area. Now, there are other commands that you can use as well. There's authentication, plain text or MD5. You can change the hello interval, dead interval, retransmit delay, transmit delay, all using the virtual link command. But the basic virtual link command is very simple. So once you've configured, how do you know it's working? Well, first, on the transit area border routers, first show the IP OSPF neighbors command. You should see the presence of the virtual link neighbor with a status of full. And in fact, the interface will say OSPF VL12 or some integer. You can also use the show IP OSPF virtual links because it'll actually show the virtual link and confirm the adjacency and the neighbor state is up. You can also do the show IP OSPF interface and it will actually show that it's up, the virtual link interface. For the discontiguous area routers, now this would be router 10 in our topology that's pictured to the left, do show IP route OSPF. You should see routes from the backbone and everything else that you would normally see if the virtual link is functioning correctly. So now we want to actually look at configuration of our advanced lab routing exercises. We're going to go over the review of the commands, the routers involved, and then how to verify that everything's functioning. First, we want to configure neighbor authentication on the frame relay area. We'll be doing MD5 authentication, so it'll be the IP OSPF message digest key command and interface configuration mode. The area, we're actually going to specify area parameters, so we'll do area, in this case area 0 message digest, and then we'll make sure it's actually functioning correctly by putting in IP OSPF authentication message digest under each one of the serial interfaces. Next, we want to configure route summarization on router 10. And all router 10 is going to do is simply suppress its loopback interface, the /32, and advertise 10.10.10.0/24. We could create route filtering on R9 and apply that with the distribute list command. We actually already configured our stub configuration on router 8 in a previous lesson, but then the final thing we want to do is to be able to configure our virtual links on R9 and R7, which is our transit area. When we configure the routers, we'll use the my OSPF key as the key between area 0. We're actually not going to configure a default route because we're actually going to do that later when we join the OSPF and EIGRP areas using BGP. We're going to create the area range command, filter the routing updates, stub area, which we've done, and create the virtual link. Verification of these is simple. We just look for the show IP OSPF neighbor command on routers 6, 7, and 8 to make sure the neighbor relationships in fact are functioning. Verify that only the 10.10.10.0/24 is being advertised. We've already done the stub area, and we'll actually verify the virtual link. Okay, now we're back in our lab environment. We're actually going to configure some of the things we talked about. The first thing we want to do is neighbor authentication, so configure terminal, router OSPF1, area 0, authentication message digest. Now interface serial 0/0, IP OSPF authentication. Do the key with message digest key, my OSPF key. One, my OSPF key. OSPF key. Oh yes, MD5, my OSPF key. Now IP OSPF authentication, Message digest. Go to router 7, configure terminal. We're getting all the complaints about the virtual link, which we'll get to in a minute. Router OSPF 1, area 0, area 0, authentication, message digest, interface serial 00, IP OSPF, message digest key, 1, MD5, my OSPF key, then IP OSPF, authentication, message digest. Now for router 8, configure terminal, router OSPF PF1, area 0 authentication message digest, interface serial 0, IP OSPF authentication, message digest key, 1 MD5, my OSPF key, IP OSPF authentication, message digest. Show IP OSPF neighbor, still coming back up. Show IP OSPF neighbor. It's attempting to bring that connection back up. While we're waiting for that, let's configure our virtual link. So configure terminal, router OSPF 1, area 79 virtual link 10.9.9.9. Now let's go to router 9, configure terminal, router OSPF 1, area 79 virtual link 10.7.7.7. And notice now our neighbor relationships are back up, so we know neighbor authentication is working, although it does seem to have forgotten about the priority commands. So interface serial 00, IP OSPF priority 0, router 8, configure terminal, interface serial 0, IP OSPF priority 0, clear IP OSPF process, yes, yes. Neighbor relationships will drop, show IP OSPF neighbor. We'll look at that in just a minute. Now we want to go back and see if our virtual link is functioning. Notice we're not getting nastygrams anymore. Show IP OSPF virtual links. It's up. It's functioning exactly as we wanted it to. Seems true on router 9. Show IP OSPF virtual links. It's functioning. Show IP OSPF border routers. And it's listing router 7 is the ABR. Show IP OSPF neighbor. Let's see what showing the relationship with R6 is fully up here. Show IP OSPF neighbor. Shows the neighbor relationship fully up here and our virtual links configured. The only other thing we were still going to do is a little route filtering. We're going to do it on router 10, but let's do it on router 9. So figure terminal, router OSPF 1, area 79 range 10.9.9.0, 255.255.255.0. Let me go back to router 7. Show IP route, OSPF. Notice all our neighbor relationships are back up. And things are in the routing table as expected. So that pretty much configures everything that we talked about: area range, neighbor authentication, and virtual links. So just as a wrap up, some key terms we want to talk about. The area range. This is the OSPF route summarization method that advertises summarized prefix at the area border router. Summary address, similar, but instead of doing it at the area border router, it's done at the autonomous system boundary router, and it's for external routes. Route summarization is the overall process of taking a large number of contiguous networks and expressing them in a reduced form or single prefix. Route filtering is the process of selectively removing routes from the routing table or routing process. In the case of OSPF, it's actually blocking information from the link state database from entering into the IP routing table. Distribute list is a route filtering method using access lists, prefix lists, or route maps to prevent OSPF routes from being installed in the routing table. And a virtual link is a virtual point-to-point link used to link a discontiguous network to area 0. So what did we cover? We covered route summarization, route filtering functionality, virtual link, configuration of our OSPF advanced lab exercises. Thank you for your attention. I know this was a lot of material. We dug really, really deep, and I trust that you find the information relevant, useful, and helpful in your career. Talk to you next time.